Hey everybody, this is Larry. This is day 6 of the February Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Yeah. Okay. So I usually solve these lives, so definitely fast forward if it goes a little bit too slow, because I try to go over my thought process instead. Okay. So given a binary tree, imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom. Okay. So I think immediately when I first see this problem, uh, I think, well, it's a tree. So at worst, it's going to be O of n or linear time. And when you do linear time things, and I think you cannot do better than that because you have to kind of visit every node. Because, for example, if just 5 has like children, then you have to go that entire path no matter what, right? So knowing that we can just look at every node once, knowing that there's a linear time algorithm, that's usually good enough for me to get started. In this problem, there's a little bit of a weird thing in that they don't give you the constraints, right? And that's okay because, like I said, if the solution is linear, then it doesn't matter whether what the complexity is because it's going to be fast enough because you just have to read the input anyway, right? Okay. And then in terms of implementation, I think there are a couple of ways you can do it. There's breadth first search, depth first search, and you can be a little bit smart about how you do it. And I think that's basically what I'm going to do. There's some invariance around implementation, but I think you just have to practice it. I think this is a very good beginner, depth first search and breadth first search. I say that way. I just mean actually recursive way of solving this, and also maybe a queue-based or level-based way of solving this as well. So definitely, do your practices. I generally, if it was a contest, I would generally would do it recursively because because nodes on a tree has a very recursive structure, and as long as you know the invariants, you should be able to solve them. But obviously that part is not as easy as I just made it. But I think this one is pretty straightforward. Though, however, so I'm gonna have a helper method. Let's call it. I'm gonna call it post order, and you'll see why I will change that later. Oh, is it post order? No, it's pre order. Whoops. I think I want pre order. Yeah, I think I want pre order. Okay. It doesn't. I mean, I think it doesn't matter if you're really careful which direction, but I think I want pre-order just to be clear on how you do it, and you could actually even do it not in order, but reverse in order from right, middle, left, or something like that. But yeah, and then we also have the answer where we just have the answer and have it in a way. You can also put it in a hash table. I think to be honest, if I was on a competitive contest thing, I would probably do it in a hash table, and the reason why is just because it allows me to not think about this probably has a depth, but it allows me to not think about edge cases as few as possible, and then we just do a linear transfer from a hash table to an array, and that'll be good enough. But here, since we do have the luxury of time a little bit, I'm going to try to be a little bit careful. So okay, so let's see, if node is none, we return, because that means that there's no node in this area. Otherwise, we want to do what? We want to process this, the current root. So then we go, but the way that I want to process it is in a way such that we only update the answer the first time we do it, right? So okay, so if length of answer is less than depth, or less than equal to, then answer dot append node dot value, is it dot, yeah, dot valve. Otherwise we just do pre-order node dot right, that plus 1, pre-order node dot left, that plus 1. And I think this should be good enough for us to go. And yeah, the reason why is that if we keep our invariant correctly, whoops, this should be 0. We keep our invariant correctly, this should only add an item at the very end, and that means that depth would always be equal to this. It shouldn't be bigger, and this would add it at that location, right? So yeah, so let's give it a go. And then the rest is just like, I think the thing with this code is that you have to prove that the first time you visit a node is the first time you update the answer, and we don't have to replace it afterwards. I was looking for more test cases. So let's give it a submit. And the reason why this is the case is because we do it in the order that is correct, which means that it is pre-order. Like again, as I say, for a given depth, as long as we do the right, we prioritize the right side of the tree, then that should be good. Yeah, let's give it a submit. Because otherwise then you might have to do some other fancy things to kind of do the type again. There you go, you get the accept. So again, what is the complexity, right? In terms of space, this is going to be O of H, which is the height of the tree, both because that's the answer array that we have to return, but also because of the recursive core stack, because at worst it's going to have an H level, O of H level core stack. In terms of time, we look at each node once, and in this case, there's no way to shortcut it because, as I mentioned before, for a given depth, the answer the rightmost node may be on the left side of something, right? So you have to look at every node. That's my basic thought about it. And if you look at every node, then it's going to be linear time or O of n. I think this is a good beginner's problem, good practice problem, and I would definitely practice these sort of problems because it comes up quite a bit. That's all I have for this problem. Let me know what you think. And yeah, it's week 1. Yay, you finished week 1 with me. Oh no, I lied. Oops. Oh, it's only day 6, so I lied. But you finished 6 out of 7 days. So everyone, this is Saturday. Have a great weekend, and yeah, stay good, stay healthy, to good mental health. Take care of yourself and take care of others around you. And I will see y'all later. Bye bye.